The DCMA 14-point assessment is a structured methodology for schedule quality review. It ensures schedules are logical, complete, realistic, and defensible. The assessment aims to enhance project success probability. This is achieved by proactively identifying and addressing potential scheduling issues. The methodology provides a comprehensive framework for evaluating schedule integrity. Ultimately, the assessment contributes to more reliable and achievable project timelines. DCMA checks were introduced in 2005 by the Defense Contract Management Agency. These checks became mandatory for U.S. Department of Defense projects. The mandate applied to projects exceeding $20 million in value. The primary goal was to protect both contractors and clients involved in these projects. This protection was achieved by enforcing consistent planning standards across all projects. Consistent planning standards ensured accountability and reduced potential disputes. The DCMA 14-point assessment is now utilized across various industries beyond government projects. These industries include construction, infrastructure, and engineering, procurement, and construction, EPC sectors. It is also applied in the energy and oil and gas sectors. Modern project management tools such as Primavera P6 facilitate these checks. Primavera P6 supports the implementation and monitoring of the DCMA 14-point assessment. This widespread adoption has established the DCMA 14-point assessment as an industry benchmark. DCMA assessment ensures an accurate critical path for project schedules. It also ensures logical sequencing of tasks within the schedule. Transparent forecasting is another key benefit of DCMA schedule assessment. DCMA assessment promotes reliable progress reporting. Schedules that pass DCMA assessment gain strong credibility. A DCMA-compliant schedule is easier to explain, update, and defend. A logic check ensures all activities are logically connected within a project schedule. Each activity, excluding start and finish milestones, requires both predecessors and successors. Predecessors are activities that must be completed before a given activity can begin. Successors are activities that cannot begin until a given activity is completed. Missing logic links can disrupt the critical path, potentially hiding risks and delaying project completion. Therefore, verifying logical connections is crucial for maintaining an accurate and reliable project schedule. DCMA rules strictly prohibit the use of leads or negative lag in project scheduling. Negative lag introduces confusion and obscures the logical sequence of activities. It distorts the intended flow of tasks, making it difficult to identify potential sequencing problems. Using shorter activities with clear finish-to-start relationships is a better practice. This approach ensures a more transparent and manageable project schedule. Lags in project schedules should be minimized to maintain schedule integrity. Positive lags, specifically, should not exceed 5% of the total relationships within a schedule. Excessive lags can obscure the true dependencies and critical path of a project. To enhance schedule clarity, consider replacing lags with explicit activities. Suitable replacements include cure time activities, waiting periods, or inspection tasks. These replacements improve transparency by making dependencies more visible and understandable. The majority of project task relationships should utilize the finish-to-start dependency. Finish-to-start logic is favored for its clarity and ease of comprehension in project scheduling. Start-to-start and finish-to-finish dependencies are allowed, but their usage should be limited. Maintaining a high percentage of finish-to-start relationships promotes better project understanding. Hard constraints are limitations imposed on project activities within a schedule. Ideally, hard constraints should apply to a small fraction of activities, preferably 5% or less. These constraints take precedence over logical relationships between tasks. Applying hard constraints removes float, which is the scheduling flexibility. Over-reliance on constraints reduces the overall adaptability of the project schedule. A well-structured schedule should primarily function based on logical task dependencies, minimizing the need for constraints. Total float in a project should ideally be 44 working days or less. Excessive float often signals deficiencies in project logic or sequencing. High float can indicate missing dependencies or unrealistic time estimates. Project managers should strive to minimize high float activities to maintain control. High float activities should ideally constitute 5% or less of all project activities. Negative float signifies a project is projected to finish behind schedule. DCMA guidelines recommend avoiding negative float in project planning. The presence of negative float necessitates a clear explanation of its causes. A documented recovery plan is essential when negative float is identified. Individual activity durations should be carefully managed to maintain project efficiency. Task durations should ideally not exceed 44 working days to facilitate better tracking. Limiting long-duration tasks promotes more accurate progress measurement. Long-duration tasks should constitute a small percentage of incomplete activities. Specifically, long-duration tasks should be 5% or less of incomplete activities. Breaking down work into smaller, manageable tasks enhances overall project control. The use of valid dates is crucial for maintaining schedule integrity. Invalid dates, such as representing future work as past or vice versa, are unacceptable. Showing future work in the past or completed work in the future introduces errors. Such inconsistencies undermine the schedule's schedul's credibility and reliability. Therefore, ensuring all dates are accurate and logically consistent is essential. Resource loading is optional according to DCMA guidelines. If resources or costs are utilized, they must be comprehensive and consistent. All activities, excluding milestones, must have a resource or cost assignment. This ensures accurate tracking and management of project expenses. Missed tasks are defined as activities that have not been completed by their scheduled finish date. Tracking missed tasks is crucial for identifying potential problems in project timelines. The DCMA, Defense Contract Management Agency, sets a threshold of 5% or less for missed tasks. Exceeding this 5% threshold indicates a potential risk to on-time project delivery. Monitoring missed tasks serves as an early warning system for schedule reliability issues. A project schedule must have a continuous critical path. The critical path extends from the project's start to its finish. A broken critical path compromises the reliability of the completion date forecast. Without a continuous path, the projected completion date cannot be trusted. The Critical Path Length Index, CPLI, assesses the feasibility of meeting the project completion date. A CPLI of 1 signifies that the project is on track for timely completion. A CPLI value below 0.95 indicates a high level of risk to the project timeline. When the CPLI is below 0.95, management intervention is necessary to mitigate potential delays. The Baseline Execution Index, BEI, is a metric used to track project progress. BEI compares planned progress against the actual progress achieved. A BEI of 1 indicates that the project is on schedule. A BEI below 1 suggests the project is behind schedule. A BEI above 1 indicates the project is ahead of schedule. Logic density is a metric used in project scheduling. It quantifies the number of logical relationships associated with each activity in a project schedule. These relationships define dependencies and sequences between project tasks. A higher logic density indicates a more interconnected and detailed project plan. Schedules with high logic density are generally more robust and reliable. This increased robustness stems from the comprehensive network of dependencies that have been established. All project activities require a clearly defined scope. A well-defined scope ensures accurate duration estimates for project tasks. It also enables effective allocation of resources to specific activities. Undefined scope can lead to inaccurate duration estimates. Inaccurate estimates and resource allocation undermine the overall schedule integrity. Project schedules must incorporate identified risks. Mitigation plans should also be integrated into the schedule. This integration ensures potential disruptions are accounted for proactively. Contingency plans are put in place to address identified risks effectively. Schedules require frequent updates to accurately reflect current progress. Updates should incorporate any changes to project scope. Resource adjustments also necessitate schedule revisions. Infrequent updates result in unreliable and outdated forecasts. A schedule basis document is essential for explaining the foundations of a project schedule. This document details the assumptions made during schedule creation. It also outlines any constraints that influence the scheduling process. The methodologies used in developing the schedule are clearly explained. Maintaining this document enhances the transparency and credibility of the project schedule. DCMA assessments offer a structured approach to schedule evaluation. These assessments ensure rigorous inspection of project timelines. They verify the logical completeness of project schedules. DCMA assessments contribute to improved project documentation. Stakeholder confidence is increased through DCMA's thorough review process. The benefits of DCMA assessments have led to their widespread adoption across various industries. DCMA assessment enhances the likelihood of project success. This enhancement is achieved through improvements in schedule quality. A well-constructed schedule is crucial for effective project management. Effective schedules require careful planning and meticulous execution. Continuous review is essential to maintain schedule accuracy. Ongoing maintenance is necessary throughout the entire project lifecycle to ensure continued schedule quality.